Alluxio is an open source project. It started as an open source project. It still is. It has actually one of the fastest growing communities out there, at least in the big data space. So it's really exciting to be a part of that. And also, Alluxio is memory speed. Alluxio heavily leverages memory to store data and keep the data close to applications. So applications get direct access and memory speed access to their data. Alluxio is also what we call virtual. Essentially, it abstracts different storage systems that you may have and provides a unified namespace to applications. And so applications can use this single global namespace for all their different storage systems, and it can be very convenient for applications. And lastly, it's a distributed storage system. So it not only is a virtual namespace, but it's also a distributed storage system. It's designed to scale out to many nodes, and later on we'll talk about some of the production use cases that do that. So here's a brief depiction of what the Alluxio ecosystem looks like. At the bottom, we have many different storage systems. So here we have some examples like Amazon S3 or Google Cloud Storage or HDFS or NFS. There are a lot of different storage systems out there that you might have data in. And then at the very top, we have a lot of different computation and application frameworks. So we have Spark, MapReduce, Flink, and so on. So there's a lot of different choices for storage, and there are a lot of different choices for computation frameworks. And so Alluxio actually sits between those two layers, the storage layer and the computation layer. It provides a unified namespace for the data in different storage systems, and applications only need to talk to the Alluxio and Alluxio namespace in order to access that data in different places. Applications don't need to worry about where the data is and how to access it, and they just need to worry about what to do with that data. And so this is sort of a brief summary of where Alluxio sits in the ecosystem and architecture. And here are some of the benefits that Alluxio does provide. So with Alluxio, it provides a lot of flexibility. So since essentially it is a layer between this computation and storage, it makes it really simple and flexible in order to add additional storage systems or add additional computation frameworks. And with the unified namespace, you can be really flexible with how you deal with your data. It can really enable agility. By being this abstraction layer and storage system, you can easily add new computation frameworks, you add new applications, add new storage systems. You can have data in different places. It just really enables a lot of being able to switch around a lot of your decisions of where your data is and how you want to compute on that data. And with Alluxio, it also provides performance. So it's a memory-centric architecture that Alluxio uses. So it heavily uses memory to store that data, and while keeping that data close to your applications can be greatly accelerated by having direct memory access to their data. And lastly, cost is another benefit that you can get with Alluxio. By essentially decoupling computation resources and storage resources, you can actually scale those independently, depending on what your limiting factor is. So by doing that, you can achieve better utilization of your resources and can reduce your costs. So these are some of the benefits that you can have with Alluxio, and essentially it enables any application to access any of your data from any storage system at memory speed. So next I'll talk a little bit about Alluxio, the open source project, the open source community, since it is an open source project. It actually started, the actual project started in summer of 2012, which was Hao Yuan's PhD project, and it started in the same lab that spawned Apache Mesos and Apache Spark. So there's a lot of similar roots to those projects. And then in 2013, April 2013, the project was open sourced to the public. And so at the time it was called Tachyon, but now in February of earlier this year, it was renamed to Alluxio. And the latest release of Alluxio, actually was, I think, a few days ago, which is version 1.1.1. So the lifespan of the open source community is about 3 years, from 2013 to 2016 now. And so it's been really exciting to be a part of that. Here is some of the contributor growth that's happened. I think currently there are over 250 contributors to the project in total. And just over the past year, from middle of 2015 to today, it's been about 3 times growth in the contributors. So it's been actually pretty exciting to see that type of growth. And here's just a small bubble, I think, of the top 100 contributors, and the size is relative to how many contributions they've made to the project. So it's really cool to see how it's growing. Also, it's exciting to see the rate at that it's growing. Here's sort of it's a plot of the number of contributors to the project during the first, several months of the several months of when it was released to the open source public. And it's been about 3 years. And so within the first 3 years, Alluxio was actually one of the, Alluxio was actually the top blue line. It's growing faster than a lot of the other popular big data open source projects, such as like Cassandra, Spark, Kafka. So it's really exciting to see this type of involvement of the community with this 3-year-old open source project. And also, there's a lot of different, these contributors are from all over the place, all over the world, and they're from a lot of different companies. So here's just a small sample of some of the contributors and users of Alluxio. As you can see, there's a wide range of different types of companies and organizations and universities and things like that. So it's really cool to see this type of adoption. So, like I said before, Alluxio is memory speed, and what that means is Alluxio, the architecture of Alluxio uses memory, it uses RAM in order to serve data or to store the data. And so you might be asking yourself, like, why do we want to use memory to store data? Like, does that even work? Well, here are a few reasons why. The first reason is that there's a performance trend in memory. The throughput of RAM is actually growing exponentially, and it's already much faster than hard drives. So if you want interactive applications, memory locality is very important. You need your applications, you want your data in memory closest to your applications as much as possible to have the fastest response times and highest throughput for your applications. So that's sort of one reason why having data in memory is very important. Another reason why that it's important is that the price of memory is actually dropping pretty fast. This is a plot of the cost of DRAM, cost per gigabyte, and as you can see, it's a log scale. It's dropping very steadily. Essentially, it's like halving every 18 months. So it's becoming very, companies and organizations are becoming more and more willing to buy a lot more memory for their machines. And they're getting a lot of machines, and they're getting a lot of memory for their machines. And so typically, I mean, it's not uncommon to hear about deployments where you have half a terabyte of memory in those machines. And so there's a lot of memory out there. So how do we best utilize that? So Alluxio really tries to figure out and tries to solve that problem for storage. And so one question you might have is, like, we have all this memory, but still it's not as big as SSDs or hard drives. Like, what happens then? Like, how will this even work? What if your data is still not, your memory is still not big enough for your data? Well, Alluxio has the concept of tiered storage. So Alluxio is sort of memory focused and memory centric, but it does also manage other tiers in the hierarchy, such as SSDs and hard drives. So Alluxio does have a tiered storage concept. It manages memory, SSD, hard drives. Obviously, the idea is that the higher tiers are usually faster and more performant, but typically have less capacity, whereas the lower tiers are typically have more capacity, but probably have a slower performance. And so Alluxio does have the concept of tiered storage, and it uses all the tiers to its advantage. And these storage tiers are actually configurable. You can configure Alluxio to have different configurations of the storage tiers. You can configure Alluxio to have just use the memory tier. You can configure Alluxio to have, you can mix and match these tiers like memory and the hard drives, or maybe only SSDs. So Alluxio is configurable in this way and really can be tailored to your workload and application. Also, there are these, Alluxio has support for tier management policies. Since we have these different tiers and we have different applications having different requirements, ideally there are different ways you can move the data around between different tiers. And so Alluxio has a few built in, but there's also there's an easy way to add new tier management policies to the system. And so the high level idea is that you would want important data or hot data closer to the top tiers where it has a lot of performance, and sort of age out or lower some of the stale data or the data that's not as important. So there are policies built into Alluxio that are pluggable as well. And Alluxio, like I said before, is a virtual distributed storage system. Here's sort of what you might see the ecosystem today. Like there's a bunch of storage systems at the bottom. There's a bunch of computation frameworks at the top. And in order to sort of connect all these together, it could get pretty messy. So there's a lot of different integrations you might have to do. You might have to move data around. It can get actually pretty messy in terms of the integrations and different storage systems and different computation frameworks. And so yeah, there's a lot of different issues that you might run into. Like it could be costly to integrate all of these together. There could be a lot of data duplication or like a lot of ETL processes that go on. There might be you might have data silos and things like that. So it might actually, managing all of this might actually take too long or take longer than you want, and it will take you longer to get value from your data. Instead of having to concentrate on, you might have to worry about all these issues instead of having to concentrate and spend your efforts on actually extracting the value. So Alluxio tries to help you with that by being by being in between the computation and the storage. You don't have to worry about all the messiness. You can focus on what you want to do with that data. So next I'll talk about how you can use Alluxio, where to use Alluxio, and how companies and some public deployments use it. So here are some of the, it's actually pretty surprising how people use Alluxio. Every time we talk to people, there's new ways to use it, but here are some of the common ways that people typically use Alluxio. First, the Alluxio can be used to accelerate access to remote storage. Alluxio can also be used to share data between applications and frameworks at memory speed. And also Alluxio can help transparently manage data across different storage systems. So these are the three that I'll sort of talk about in a little bit more detail. So yeah, Alluxio definitely can help a lot with accelerating data access to remote storage. So here's an example. Say we have Spark, which is a very common application framework, and then we have Amazon S3. Say that's where our data is stored. If you wanted to run any application on this data, you'd have to read that data and write that data out to S3, and that could potentially take a long time. And the reason for that is because, especially in this situation, you have to go over the wide area network. You have to hit disk eventually and things like that. So you're basically, there's a high latency to the data, and there's also a lower throughput of that data. So you're limited by that link. However, when you use Alluxio there, you would actually put Alluxio between the computation frameworks and the storage systems. So here, Alluxio, there are times when Alluxio still has to talk to the storage system. So in that situation, it still has to talk to S3 and still has to go over the wide area network. However, once it's in Alluxio, the applications can immediately access that data very quickly, potentially at memory speeds if the data is in the memory tier. And so that latency is actually much lower. The throughput can be memory throughput to that data. So there's a lot of advantages there. Alluxio can, by keeping your data in Alluxio in memory close to your computation, can really accelerate your applications in that way. Next, Alluxio can also help you share data at memory speed. And so sharing data can actually be very, very, very costly and very slow. Here in this example, we have some storage system. Here it's S3. And we have several different applications. So we have a Spark application, MapReduce, and Think. And say it's sort of like a pipeline. So sort of the results of the Spark application is the input for the MapReduce application. And then the result of the second job is sort of the input to the third job. So it's a pipeline fashion. So in order to actually run this pipeline and share the data between these jobs, you actually need to read and write from your storage. And so by these slow arrows, as you can see, it can take a long time. And the reason it takes a long time is because you could potentially go over the network, write to a bunch of disks, so it may slow down your pipeline. So instead, if you put Alluxio in the middle, you can actually improve this pipeline by a lot. And so, the first time you read and write data, you do have to hit the storage system. But once it's in Alluxio, you can share that data at memory speed. You can read and write data to the Alluxio, which is at memory speed, which is stored in memory. And so you can do that, and then finally write out the final results to the storage system. And so by doing this, you can essentially share the data between jobs through memory instead of having to go over the network and over to the disk. And finally, Alluxio helps you manage data that sort of sits across different storage systems. Say you're in this simple world where you have one storage system. Here it's HDFS, and you have one application, and it's really easy to sort of interface between those two. But say you hear that, oh, I heard that cloud storage is getting hot, like I want to use that. So then you want to add the cloud storage system to your architecture. Then you can sort of add S3, and then finally you can try out the Google Cloud Store there, and then finally you have to interface with that. So you have additional interactions that you would have to implement. And then next you have a new application, or maybe it's a new framework, a new application. You would have to sort of make sure that all of that works with your existing data and storage. And finally, if you have a third application you want to add, you have to sort of make sure all this works. And so this could potentially be very complex and very complicated and inflexible. So some of them may not work, or it might just be hard to get them integrated. So with Alluxio, in the simple case, it's the same. The applications talk to Alluxio with an API, and then Alluxio talks to the HDFS with some API. But so as you add new storage systems and applications, it's actually the picture looks much simpler since the interactions from Alluxio to the storage systems only need to happen once, and the integrations between the applications to Alluxio really only need to happen once. And so it really greatly simplifies the environment and the deployment story for different things. And also, it doesn't require new application changes, because you're essentially pointing to different files or directories in the namespace. So it's very flexible in that way, and you can easily add new storage systems quickly. So next I'll talk about sort of what's going on out there in Alluxio, how people are using Alluxio out there in the public. And so I'll talk about three different use cases in how, three public use cases that people have been talking about recently with Alluxio. So the first use case I'll talk about is a use case with Baidu. They're essentially the Google of China. And at Baidu, they're using Spark, and they're using Spark SQL as essentially their computation engine. They have their sort of customized Baidu file system that stores their data. And they use Alluxio between Spark SQL and the Baidu file system, and they use the memory tier and the HDD tier in Alluxio. And they actually have a large deployment, over 200 nodes. They actually went into production like probably a year ago, so they were actually one of the earlier adopters, and actually probably had a very big deployment even last year. So it's actually was pretty exciting to hear about that last year. And they actually manage over 2 petabytes of space in Alluxio. And the reason that's possible is because they're using the tiered storage concept. They're using memory as well as hard drives, which allows Alluxio to manage more of that space. And then they actually got 30 times speed up with Alluxio than without Alluxio. So they had essentially before Alluxio, they just had Spark SQL talking to their file system. And then with Alluxio, they got 30x speed up, which is really cool. And so they actually wrote a white paper on this, and you can actually find this white paper on the website alluxio.com. And so they talk a little bit more about that. Next, I'll talk about a use case that Barclays has blogged about. And essentially, they're using Spark. They're actually using both Spark RDDs and Spark data frames, things like that. They have a primarily machine learning type of workloads. They use Alluxio between. Actually, they use Alluxio with just the memory tier, so no other tiers are involved. And essentially, they had before they had to whenever they had new Spark contexts and applications, they actually have to read that data in every single time. And so instead of reading the data every single time, they would actually store it in Alluxio once and then read it from Alluxio whenever they needed it. And so since it was in memory, they could actually really speed up a lot of those jobs. And so instead of, so each of these imports of data into Spark actually took 30 minutes to an hour. And so instead of doing that every single time, they actually kept it in Alluxio and just read it from Alluxio each time, which is why they got, a lot of their jobs went from hours to seconds. And so they actually wrote a blog about this, which actually it was back when it was called Tachyon, but they wrote a blog about this and sort of talks about more of how they got that to work and what improvements they achieved. And lastly, I'll talk about this third company that publicly have talked about. They actually blogged about something with Alluxio. This is Chunar. They're essentially like a travel company, Expedia, in China. And they actually have a very interesting architecture. They have a lot of different frameworks that in their architecture. They use Spark and Flink and both the batch APIs as well as the streaming APIs. So they have a lot of different frameworks running. They have a lot of different storage systems, and they have a lot of different clusters of storage systems as well. So there's a lot of different storage systems, a lot of different frameworks, and they actually put Alluxio in there to actually help them manage all of that. And then on top of that, they actually got a lot of performance improvements as well. So they have actually a large deployment as well. They have over 200 nodes that they're running with Alluxio. And with Alluxio, so before Alluxio, they actually had some jobs that actually couldn't finish. And the reason they couldn't finish is because the jobs would sort of run out of memory, and they couldn't finish. The computation jobs would run out of memory. So by not having the computation store all that data and have Alluxio store that data, they didn't have to. The computation jobs didn't have to store all that data in their memory. It could just run what it needed to do, and all the data would be in Alluxio instead, and all the jobs would be able to finish. And they also, during sort of the peak times of their daily operation, they actually got 300 times performance improvement because instead of having to access the storage all the time, they would access it from Alluxio instead, and they actually not have to incur the network latency. And so that's sort of the summary of their use case. So yeah, in summary, this is essentially, Alluxio is a memory speed, it's an open source memory speed, a virtual distributed storage system. It sits between existing storage systems and your computation frameworks. And here are additional links to get more information. We have the open source project page at alluxio.org. The company website is alluxio.com. We have all of our source codes in GitHub for Alluxio. And we have a meetup in the Bay Area. So if you guys want to start one down here, that'd be great too. And you can always email me at gene@alluxio.com. Thank you very much. So yeah, now I guess we can go into some questions.
So they're probably both kind of obvious questions, but first one is about locality. what happens when you're in a cluster and the data you want to access is not on the node, where you are, where you're processing. The other one is about predicate, is the idea of predicate pushdown. How does that work through Alluxio? If you, that's where a lot of performance comes from in other systems. And if you're all in memory, then I guess that issue kind of goes away. But if you're in a tiered system, then does it work?
Sure. So the first question was about locality. So for locality, if the data is not on, so we typically recommend deploying Alluxio with the computation frameworks. And so by doing that, it's more likely to have that data on the same machine as the computation framework. And if that's the case, that's obviously the ideal situation. If for some reason the data is not on that machine, then obviously you have to go get it. It won't magically appear in memory, but you do have to go get it. But we do have, you can configure it such that once you do go get it, you can keep it on your machine as well. And so the next time you do, if you need to get it, it'll be on the local machine. For the other question about pushdown, Alluxio essentially provides a file system interface. So you can read, write files. You can, there are directories and directory structures and things like that. So in that sense, the predicate pushdown would probably happen on top of files. And so Alluxio essentially provides the file system interface. Back there? Yeah, that's interesting. So the question was essentially, how does the data transfer in Alluxio compare to the data transfer in Spark Shuffle? So I don't know the answer to that question. We haven't done any sort of, we haven't tried to do any sort of a comparison between the two types of data distribution mechanisms. So did you say that someone has already tried to do tachyon and TensorFlow? Oh wow, that's really interesting. I'll have to look into that. Yeah. Yeah, that's really interesting. So I mean, I'm not aware of that, and I don't know too much about that project or how it compares to Spark Shuffle, but yeah, maybe we can talk offline and we can sort of talk more about that.
All right, folks, we'll take one more question.
Sure. Yeah. So you mean attaching ZFS to Alluxio and seeing what that does?
Yeah, because in that sense, ZFS components
Yeah. Mm-hmm. Yeah, so that's a good question too. I am not aware of anyone doing that sort of comparison. I think, yeah, so I think what Alluxio, so Alluxio would probably treat the ZFS mount as essentially like actually no. Yeah, so I'm actually not too familiar how that comparison works. There's actually different ways you can integrate ZFS into Alluxio. You can use, if the entire node was on ZFS, that's sort of one concept that you could think about. But you could also think about if you could sort of attach ZFS into essentially mount ZFS into Alluxio namespace, and then see if that affects anything as well. So I'm not aware of any comparisons between those two systems, but yeah, I'll be happy to talk more about it later.
Yeah, if you actually
Okay.
Kind of the GFS line, you have very good architecture.
Sure.
Because the layer of DRAM, and the layer of SSD, the layer of SSD, so I mean, obviously, that's the connection that you can use for the GFS line. Sort of goes along the same line.
Cool.
That's what uses the GFS.
Yeah.
So it's just
Yeah. Thanks. Thanks for the info.
All right, thank you, Gene. Please
Thank you, everyone.
give a round of applause. We are serving lunch downstairs, so feel free to make your way down.